Back in the early 2020s, I was sort of seeing the writings on the wall. I saw that generative AI was essentially going to keep scaling until we run out of energy.
The energy usage of the AI is exploding at exponential rate, and that is the bottleneck for any of the advancements in AI.
If you want agentic AI that's always on and potentially controlling robots, executing these world models, we need to not only double our grid in the US, but maybe potentially 10x it with the current algorithms and the current stack that we have at the hardware layer. Most workloads that we want to run on these deterministic computers, be it GPUs or TPUs, are actually probabilistic. And so I wanted to build a probabilistic computer for the era of probabilistic software, but a probabilistic computer that operates at the physical limits of energy efficiency. And so we're fundamentally talking about the thermodynamics of information processing at that point. So that led me to pioneer thermodynamic computing.
In thermodynamic computing, the idea is to harness natural sources of entropy occurring in nature to do stochastic computation. The idea of thermodynamic computing is to build a machine that converges towards an equilibrium distribution.
Everybody in physics knows the fable of Maxwell's demon, and so it didn't make sense to me that we would pay Maxwell's demon every clock cycle to know deterministically the state of our computer if we are to run a probabilistic workload on top of it.
What makes Extropic unique is the fact that we're trying to use natural sources of noise present in electronic circuits to do sampling tasks.
Thermodynamic sampling units, first of all, are machines that sample from parametrized Boltzmann distributions. They're the best way to parameterize a distribution with the least amount of statistics you have to estimate. And the beauty is that physical systems can give us Boltzmann distributions. We use about 10,000 times less transistors than if you were to do it digitally on a deterministic processor. Furthermore, all of our transistors operate sub-thresholds. We use far fewer electrons. So it's not a magical number that came out of nowhere. We're just using far less elements and operating them at much lower power. And so it's both an algorithmic architecture and component level innovation that yields that massive energy efficiency gain.
To improve the energy efficiency, we need to reinvent the entire stack. We are not just trying to improve the energy efficiency to 1x, 2x, or 10x improvement. We are trying to go for 10,000x because that is what is needed for the future of AI. The existing tools are limited, and so we need to create our own tools to help us design the circuits that are required for this AI hardware.
In noisy electronics, there's a kind of noise that's present that's pretty bad. It's called 1/f noise, and the reason why it's bad is because it's naturally scale invariant. So that means that you can't really filter it out. And one of the questions that we've been studying is how do we combat that 1/f noise? Or is it even needed? Like, do we even need to filter it out for what we're trying to do? The kinds of algorithms that you're running in thermodynamic computing, the errors don't accumulate because the system is always equilibrating towards equilibrium. And the natural process of equilibration cleans up errors as they accumulate in the system. So they actually saturate, they don't accumulate indefinitely. So in that sense, the kind of computation that thermodynamic computers are doing is more robust to noise.
The biggest challenge to take this scientific vision and implement as a manufacturable device is innovation across multiple fields, from algorithms, applying physics principles to the fundamental devices in the circuit design.
If we can densify intelligence by a factor of 10,000x in terms of energy efficiency, it means that intelligence in silicon will become far more pervasive. It's going to be much cheaper. It means that we're going to be able to imbue intelligence in all sorts of everyday objects. Really having intelligence just be far more ubiquitous will lead to us living much more prosperous and comfortable lives. And we need far more people interested in this because it is very urgent that we solve this problem. And working on this problem is the way as a physicist to have the greatest impact on the advancement of civilization.